All right, welcome to the last lesson of this unit. Yay! Piecewise function, absolute value, rational functions. And then we've also talked about long and synthetic division, partial fraction decomposition. We've done a whole lot. We're now in the last step where we are graphing step functions. So what is a step function? It's a type of a piecewise function that's defined by constant values. Okay, so basically y equals some number. So you're going to have horizontal sections that are sketched. You're going to cross the y-axis and have just a bunch of horizontal line segments as you go through. So a couple of things to remember. Look for each domain of each section. So hit that so you know from what x values you want to graph the function. And then the other part is just remembering, and we saw this in the piecewise functions in the beginning of the lesson, we have a closed circle for anything that has a less than or greater than or equal to symbol. We have an open circle for the less than or the greater than. Just a quick little recap on that just to remind you guys. All right, let's get graphing. Here we go. So example 1, graph f of x equals 2 when -4 is less than x less than -1, 5 when -1 is less than x, which is less than 5, and -4 when 5 is less than or equal to x, which is less than or equal to 8. So we've got 3 separate sections. I'm going to graph y equals 2 between x equaling -4 and -1. Okay, make note of the circles that you have. Both of those are going to be open circles because they're just less than symbols. So I'm going to go to -4 on the x-axis and -1. I'm going to go up to +2. That's my y value. Y equals 2 at -4 all the way across until I get to -1. There you go. That's it. You got that section. Now do the next one. Y equals 5, okay, and that's between -1, x equaling -1, and x equaling +5. So x equaling -1 and 5. So at -1, I'm going to go up to the 5 on the y values, put another open circle for both of these guys. I'm going to travel across until I get to 5 for the x value, put another open circle. You're done. And last but not least, y equals -4, and that is between the x values of 5 and 8. These are both closed circles. So at 5 on the x-axis, I'm going to drop down 4, put a closed circle, go over to 6, 7, and then 8. It's actually off the graph. That's okay. And there are my segments. That's it. You're done. So what's your domain? We got to look at that very, very specifically. We're starting at -4 and we're going to +8. Okay, so at -4, it's an open circle to -1. Union, the next section is from -1 to 5. Again, both open circles, so both parentheses. And then union, in the last section that I graphed, the 5 and the 8 on the x's are both included, so those get brackets. Alrighty. Now I'm going to write the range a little bit differently than some people may. The only range values that I have are -4, 2, and 5. So some people just list them. Some people put them in brackets because it is only those y values. So you can kind of see that either way. And you could also use different notation as well. All right, do we have any points of discontinuity? We sure do. We have several of them. Our points of discontinuity at x equaling -4, which is the point -4, 2. At x equaling -1, and that's at 2 different places, at -1, 2, and at -1, 5. And then we finally have a third point of discontinuity at x equaling 5, and the open circle occurs at, let's see, 1, 2, 3, 4, 5. So it's the ordered pair 5, 5. Okay. All right, and then our end behavior. As the x's approach, they're not going to negative infinity. They're approaching -4. That's a little bit new because the graph doesn't go on forever. The y values, f of x approaches 2. That's the y value that follows that point. Alrighty, and then the last part is, as my x's approach, are they going to positive infinity? No, they're stopping at 8 for the domain, and those y values are approaching, that's right, -4. You got it. So those, they're not hard to do. You just have to be very cautious when you're listing domain and range as well as your end behavior. So just easy to graph, a little fussy with some of the other info. All right, let's try another one. F of x equals 3 when x is less than -2. Okay, so I'm just going to go to y equaling 3 and start at -2 for the x. So -2, 3 is my first point. That's an open circle. And it just says everything less than that. So that one's going forever and ever. Cool, I like that. Our next one is 1 between -2 and 3. So y equals 1 between x equaling -2 and +3. And I have a closed circle and then an open. So when x is -2, my y value is 1. That is a closed circle. I'm going to travel all the way across to +3 on the x values. Finish that one with an open circle. And then our last part of this is 2, y equals 2, and that's drawn between the x's of +3 and 5, and both of these are closed circles. So when x equals 3, I'm going to go to, oops, I graphed the previous one. Guys, eek, I made a mistake. Catch that. I was up too high on that one. So I'm at the point -2, 1, open circle, closed circle. And then 3, 1, open circle. There we go. Forgive me. All right, so the last one, we need to go to y equals 2, x equals 3. So the point 3, 2 starts with a closed circle, go 4 and 5 and close it out. Okay, so what is our domain for this function? Well, the red portion of the function is pointing all the way to -infinity. That section stops at -2. It picks up again, but we include the value at -2 now out to 3, parentheses, union, and then a bracket from 3 to 5. That's that entire domain that we have listed as inequalities written in interval form. All right, the range, again, I do it a little bit differently than some people, okay? So the y values that we have are 1, 2, and 3, or 1 with a bracket, 2 with a bracket, and 3 with a bracket. Okay, you might see it written that way. Points of discontinuity. Where's our graph? Have open circles. That's right, we have one of them at x equaling -2, which is the ordered pair -2, 3. We have another one occurring at x equaling +3, which is the ordered pair 3, 1. All right, check our end behavior. So as the x's go to -infinity, they are going to -infinity. Check, because that red section, look at the red part, it is going, pointing forever and ever and ever, okay? So as the x's are going to -infinity, in this case, those y values, f of x is approaching +3. And then as x approaches positive infinity, no, not positive infinity, but 5, that's where it stops. Again, look at the blue graph for this one, its domain. The y values, f of x is approaching 2, because that's its y value. Okay, good deal. We got a couple more of these? We sure do. Here we go. Number 3, graph f of x equals 6 between -2 and 0, 4 between 0 and 2, and 2 between 2 and 4. So the first one, y equals 6. I have a closed circle at the -2, open at the 0. So at -2, I'm going to go up 6, closed circle. I'm going to sketch it to x equaling 0, put an open circle. Check. All All right, next one, y equals 4. Start at 0 and end at 2, so go up to y equaling 4 at 0, put a closed circle, travel over to 2 for the x's, put a open circle. And last one, y equals 2, between 2 and 4, so I'm going to go to the point 2, 2 with a closed circle, travel over to 4, end it with an open circle. So each of those started with a closed and ended with an open. Yay, that's kind of nice. Started with a closed, end with an open. All right, domain. This one has a specific domain. The farthest left value that I have on the x's is -2, travel to 0. Union, bracket at the 0, travel to 2, parentheses. Union, start at the 2 with a bracket, travel to 4, parentheses. The range, what are the y values you have? 2, 4, and 6. Okay. Points of discontinuity occur at x equaling 0. The open circle is at the ordered pair 0, 6. At x equaling 2, the ordered pair with the open circle is at 2, 4. And x equaling 4, and again that open circle is at the point 4, 2. We're going to have a very specific end behavior because these are line segments, so I'm going towards infinity and negative infinity, but I'm not going there. Okay, we have particular values. So as x approaches -2, that's the domain of our red graph. The y values, f of x approaches, what height was that one at? That's right, that one's at 6. And then as x approaches, let's see, 1, 2, 3, 4. That is the x value of our blue graph on the far right. Those y values, f of x approaches +2. All right, last one. F of x equals -5 between -3 and 0. 0 between 0 and 3, and +5 when x is greater than or equal to 3. All right, first one, y equals -5. Okay, that's between -3 and 0. Open circle, closed circle. -3 less than x, less than or equal to 0. So at -3, -5, I am going to put an open circle. At 0, -5, I'm going to scooch over, oopsies, 1, 2, 3 units, I'm going to put a closed circle. There we go, first one done. The next one, 0, y equals 0. When 0 is less than x, which is less than 3. Both of these are going to be open circles. So at 0, 0, I have an open circle, and then at travel over to 3, the ordered pair 3, 0, I have an open circle. And last but not least, y equals 5 when the x's are greater than or equal to 3. So at the ordered pair 3, 5, we're going to have a closed circle, and I'm going to sketch that ray all the way out because it's saying greater than or equal to. I can take it as far out as I want to the right. All right, what's our domain? The farthest left value that we have is -3. It is not included. We travel to 0 with a bracket. Then we pick up again at 0 and go from 0 to 3, both parentheses. And then we pick up again at x equaling 3 with a bracket and travel out to positive infinity. And that is because the blue section, that last part of our piecewise function, is every value greater than or equal to 3. All right, our range values are -5, 0, and +5. List them or just write them in brackets. I'm good either way. Where is the function discontinuous? We have open circles, points of discontinuity, when x equals -3 at the ordered pair -3, -5. Again, when x equals 0 at the origin, 0, 0. And then finally, at x equaling +3 at the ordered pair 3, 0. End behavior, be mindful, as x approaches, what's the farthest left x value? That is correct, -3, domain of that red function. Okay, So as those x's approach -3, the y values are approaching -5. And then to the right, as x approaches, this time we can use positive infinity because that last section that we have said 3 and greater. So all of the x's from 3 on and up. All right, and then as x approaches infinity, f of x approaches that particular y value, which is +5. Great job. That's everything for this last lesson. Make sure you guys are practicing, and as always, see me if you have any questions. Thanks, guys.